Welcome back for another invigorating unit in our mathematical and algebraic thinking unit. We are in lesson 4.3. We have done order of operations, we did translating simple expressions, and now we are moving on to translating expressions with more than one operation, which is linking it to lesson 1 with the order of operations. Pretty fancy. Our lesson goals are to write mathematical expressions, aka word or number expressions, numerical expressions, by interpreting number stories. Again, the same thing as word problems. And then to translate complex mathematical expressions into number stories. So turning those same problems, number problems, into our own word problems. Some questions you might think of today. How can you write expressions with more than one operations? Which words indicate number operations? And how do you know if an expression has parentheses? The last one is a tricky one, and probably one that you'll kind of question your whole life. No, I'm kidding. But definitely one that you might need some more practice on. It is a little trickier. So again, you should be working along in the Moodle course to help you through this. This video is just to kind of work through your workbook with you and help you fill out some things and think through things. Sometimes we just need that extra pep talk. So we're going to be looking at our warm-up here, which is also in your Moodle course. Your warm-up today says the number of leatherback sea turtles, we saw these, it was like 1,323, if I remember correctly. In a reserve in 2018 was 22, and a reserve is just like a little habitat for them. The number increased by 3 turtles in 2019 and then multiplied by 4 in 2020. Write an expression to represent the number of sea turtles in the reserve in 2020. So it does not want to know how many turtles we had in 2020. We want an expression. Again, that's bolded, so kind of important. Then we want to calculate the number of sea turtles. So first we're going to write our expression, then we're going to solve it using our order of operations, of course. So let's reread this problem again. The number of sea turtles in a reserve in 2018 was 22. So I'm going to write in 2018, there were 22. Okay, simple. The number increased by 3 turtles in 2019. Increased by means to add, so I'm gonna just keep my addition sign here and add 3. And then in 2020 it says multiplied by 4. So I'm gonna write times 4. Okay, so progressively we got a lot more sea turtles really fast. So it says write an expression to represent the number of sea turtles in the reserve. So if I just take what I wrote here, 22 plus 3 times 4, okay? Am I finished? Okay, one of our guiding questions says, how will I know when I need parentheses? Well, let's think about this problem. Let's give it the context. So these numbers came in numerical order, a specific order that was important. I didn't just start with 3 turtles that multiplied to 4 and then added on 22 at the end. I did this in a specific chronological order. So when things have to be in a chronological specific order like that, you're going to want to see if you need parentheses in the problem. And what I mean by that is if I was just adding or just multiplying, I can add all day in any order. I can multiply all day in any order because the commutative property tells me I can. But here I'm adding and multiplying. So because of my order of operations, I really would have to, if I just left the expression this way, I would have to multiply first. But that doesn't make sense because I didn't just start with 3 turtles. I started with 22 turtles. So I'm going to have to put parentheses around the first thing that happened. And that was my 22 turtles gained 3 little friends in 2019. Then all of those turtles, that 25 now, multiplied by 4 in 2020. So now that I have my correct expression, let's write her down here. 22 plus 3 times 4. And then I'm going to follow my order of operations. We have our PEMDAS here. Parentheses, I did put some parentheses in there, so I got to solve those first. 25. Okay. Bring on down what I have left. Since I only have one operation left, I just have to do that operation. Thinking in quarters, even if you don't know your multiplication tables, I know that a quarter is 25 cents and 4 of those make $1. So 25, or 4 25s is 100. So there were 100 sea turtles. I'll abbreviate here, sea turt in 2020. Okay, again, it's nice to give that context to your answers. Whew, lots of stuff going on here. All right, let's move on to the next page. We got a fun activity. I'm excited for it. But first, you have to look in your Moodle course. Moodle, sorry, not Moodle. Our Moodle course. Remember, you have a video to watch in there and some notes to take down here. So here it gives you some operation words review, which are going to be key to listen and look at and maybe even come back to when you need them because, hello, you got to memorize those. Okay, you're not going to be able to use this activity workbook when you're taking your test. So I know it's a lot of words. Hopefully you already know what a lot of these words mean or can use your big brain to figure it out. Okay, apply them. Use that knowledge that you already have. So go ahead, go watch that video, then come back to me and we will do this fun activity. So our activity starts on page 20 in our student workbook. Again, if you don't have the physical workbook, just pull it up on Teams and Miss Russler should have uploaded it right there for you. So this is not a partner group activity. It is a little lengthier than our other activities, but lots of fun. If you like mystery, things like Clue or escape games, this is kind of it's a whodunit. It's a mystery. I love mystery. Mary Higgins Clark, my favorite mystery author. I started reading her in middle school, and she has lots of books. They're all murder mysteries, and they are awesome. Just a little plug there for a good author, if you like chapter books about mysteries, of course. So, the objective says, can you help the detectives figure out who committed the crime? To solve the crime, you need to figure out who committed the crime, where the crime took place, and what was used to commit the crime. So kind of like a math clue. If you've ever played the game Clue, you have to figure out who did it, where they did it, and what was used to do it. How to play. So first you will have to read the written expression in column A. And what they're referring to is this next page, this written expression right here. Okay, so all those expressions is what they're referring to. Then it says, then write an algebraic expression, which means turn it into numbers, and maybe even variables, in column B that matches what it is in column A. Then it says, next, find that expression on the list of suspects, weapons, and locations, and put a check in the box. That person, weapon, or place has now been eliminated. So you actually have to solve all of these, or you have to go through your list and narrow things down. Once you have finished all the problems, you'll have one left in each category. The only who left committed the crime, the remaining what is the weapon they used, and the final where is where the crime took place. Choose a who, what, and where. Quiz a friend or someone in your family by having them solve 3 expressions to figure out who done it. Okay, so let's go ahead, let's look at some of these and just practice a little. I'll do maybe 3 with you, okay? So who done it? Let's